Hello guys and welcome to Math Zone. In this video, we are going to learn about function. We are going to focus on domain and range. Let's look at what is a function. We can imagine our function is like a number machine where you put a value to our machine. We call it input and then we'll get the output. The input, we use the variable x. And then when you put it into the machine, which is fx, you will get the output, which is y or fx, the same thing. Let's look at the example of simple function, which is fx equals to square root of x. We can put a value to our function. For example, we put x equals to 1. We put into the machine and then you'll get the output. How to get the output? Just use the formula or the function given, which is fx equals to square root of x. And our x is equals to 1. So you will get 1. You can put another value, for example, x equals to 0. And then you'll get the output, which is square root of 0, which is 0. You can put another value, which is 2. And then you'll get another output, which is fx equals to square root of 2. Now, let's define what is domain. Domain, guys, is all possible values of x that can go into the function. All value of x. So you can put x equals to 1, x equals to 0, x equals to 2, x equals to 100, x equals to 1000. All of them are our domain. But is it all numbers can go into our function? The answer is no, guys. Because, for example, if I put x equals to negative 1, I put it into our function. What do I got? Well, just use the formula. But there is a problem. You will get square root of negative number, which is math error. That means x equals to negative 1 is not part of our domain. But all of this part of our domain. So that is the definition of domain. We have to put all possible value of x that can go into the function. Now, what is range? Range is all possible values of y that come out of the function, means that all of our output that you can get from our machine. For the domain, is like all of possible input that we can put into our function. Sometimes can be all values, all numbers, but sometimes not. For this case, all of this is part of our range, because all of this are our output. What is the example that is not our range? Well, you cannot have fx equals to negative number, for example, negative 2. This is not within our range, because we cannot get a negative number from a square root. Square root always give us a positive values. So that is the definition of range. Now guys, let's look at some example of a function and how do we find the domain of those functions. The first one, guys, we have a linear function. Let's say I have a linear function fx equals to 3x minus 1. Let's think about the domain and range that we have. Imagine this is like a machine, and then we think about what are the values that we can put into the function. Well, can we put positive value? For example, positive 3? Well, yeah, we can get the output, which is equals to 8. Can we put a very big positive value, which is 10,000? Yes, you can, because you can get the output. You can just calculate that. 3 times 10,000 minus 1. You get the value. Can we put x equals to 0? Yes, you'll get another value, which is negative 1. Can we put very big negative value, minus 100,000? Yes, and you'll get the value. So that means no matter how big, how small the value is, we can put that into our function and we will never get an error like before. Before we have square root of negative 1 is an error, but we will never get that type of error. That means all value are our domain. That means we can say the natural domain is x is all real number. This is how you write x is all real numbers. Now, let's look about the natural range. As you can see from the example, my output can be a small positive value, can be very big positive value, can be negative, can be very big negative. So our function can reach all values. That means our natural range is y is all real numbers. Means that our function can reach all numbers. But why I have natural term here? Because in the question later, the domain is usually restricted and given in the question. Natural means that the biggest domain that we can have, that's the natural, the biggest domain that we can have, which is all numbers. But later in the question, the domain is usually restricted. Now, let's look at our graph. Fx equals to 3x minus 1. The graph is kind of like this. Now, in a graph, how do we think of the domain? The domain is like how far the graph can go horizontally. Means that, as you can see, the graph is going up forever and going down forever in a linear function. So that means the graph can goes forever in a positive direction. We call it positive infinity, and can go backwards infinitely, never ends. So that means our domain is all real numbers. How about our range? It's the same. Yeah, y real numbers means that in the graph, range is just how far the graph can go vertically. Well, it can go up forever and go down forever, means that it includes all values of y, all real numbers. So that is domain and range of a linear function. Okay, now let's look at radical function. Radical function is just a function with a square root. For example, I have fx equals to square root of 2x minus 1. Let's think about the value, all value that we can put in our function. Imagine this is the function, the machine. And then we think about what values that we can put in to our function. Well, can we put x equals to 1? You calculate and then you will get fx equals to square root of 1. Well, it's okay, no problem. Can we put x equals to 0? There's a problem here. Your fx will become square root of negative 1. which is once again math error. That means not all value of x we can put into our function. So that means the natural domain is not all real numbers. But what is that? Let's think about our function. The thing is, we can put all value of x as long as inside the square root is a positive value or 0. So for example, I have x equals to half. You put it into a function, and then you will get fx equals to square root of 0. And it's still okay. It's not an error. So that means we can put any value of x as long as inside the square root, more than equals to 0. So this is the key. So to find the natural domain of this function, we need to find it, which is, the key is everything inside the square root, let's call it gx, or just use 2x minus 1 directly. Everything inside the square root must be bigger than equals to 0. Inside the square root has to be positive and can be 0 as well, but cannot be negative. And after that, you solve for natural domain. Let me move it down. So at 1, both sides, you will get 2x more than equals to 1. And then divide by 2 both sides, and then you will get x more than equals to half. So that means our natural domain for this radical function is x more than equals to half. How about our range? It's very simple, because the square root always give us a positive value, can give us 0 as well, but will never give us a negative value. You will never get fx equals to negative 2. No, because the output of a square root always positive. So we can say the range of the radical function is y more than equals to 0 for this case. If you look at the graph looks like this. This is half. And then if you want to analyze the domain and range by looking at the function, remember, domain is just how far the graph can go horizontally. Well, it can go from half and goes right. Means that x more than equals to half. Just goes to the right. But it cannot go left because it's undefined there. It's error. Natural range, y more than equals to 0. Means that how far the graph can go vertically. Well, start from 0 here, y equals to 0. Yeah, start from here. Y equals to 0 and then goes up. It will goes up forever. If we continue this line, it will go up forever. And then this is our range. So that is our radical function, guys. Okay, now let's move on to the quadratic function. In the quadratic function, for example, I have fx equals to x squared minus 4x plus 3. How to find domain and range of our quadratic function? We already learned in the first chapter that quadratic has a maximum or a minimum value that we call it as a turning point or a vertex. So recall how to find the vertex. We have to change our form into a completed square form by doing completing the square. So I have this example. Let's do completing the square to find the maximum or minimum point. So we have y or fx equals to x squared minus 4x plus 3. In order to find the domain and range, we need to find the maximum or minimum point of the quadratic. So we just need to change it into completed squared form. How do we find it? We just take our b value, which is minus 4, and then we divide it by 2. We will get minus 2. So we put y equals to x, and then we take this number, minus 2, and then we square it. And after that, we expand this first. X minus 2 squared become x minus 2 times x minus 2, and then you will have x squared minus 2x minus 2x plus 4, which is x squared minus 4x plus 4. If we expand this, you will get plus 4, but our equation plus 3, that means from 4 to 3, we minus 1. So we put minus 1 over here. So this is our completed square form. Now, by knowing this, recall we can find our vertex. Our vertex is at, if you have this, ax minus h comma k, our vertex is the h and the k. So it becomes minus 2 as our vertex. Yeah, we take the h here, we don't take the negative. Yeah, and then we have k, which is minus 1. So the vertex is 2 comma minus 1. Now, by knowing this, we can just plot the graph, just sketch. 2 comma minus 1 is our vertex, so it's around here. This is 2, this is minus 1, and this is our vertex. Because our quadratic function, the a value is more than 0, which is a number in front of our x squared. Yeah, it's positive. Yeah, positive 1. So that means the shape is facing upwards, kind of like this. So our vertex is a minimum value. So for this case, our natural domain of our quadratic function is how far the quadratic function can go horizontally. Well, it can go left and right. Yeah, it's opposite. Right and left and right. It can go right, can go left. So our natural domain is x is a real number, where we can put any value of x, no problem. There is no value of x that makes this function math error. But our natural domain is different, because we have minimum value is the y equals to minus 1, and then the graph is facing upwards, means that the range will be minus 1 and up. Means that our range is y more than equals to minus 1. But what if our a is negative? For example, this is our function. I already give you the completed square form to be quick. Well, we need to find the vertex, because the volume of the vertex, we have a x minus h square plus k, and the vertex is h comma k. That means our vertex for this function, pay attention, this is like x minus h, the vertex is h. This one x plus 3. That means the vertex is the opposite, which is negative 3. This is negative value, you take positive. This is positive, do the opposite, negative. But this one, we take the number directly for the k, which is minus 4. So our vertex is minus 3, comma minus 4. So doesn't look good. So let me redraw it. So this is our y-axis, this is our x-axis. And then our vertex is at minus 3, comma minus 4. So minus 3 is here, minus 4 is here, and then you will get your vertex. And then because our a value is negative, means that is facing downward like this. Now, The natural domain is the same thing. X real number. You can put any value of X. Positive, negative, small positive, very large positive, 0, any numbers. No problem. But the range, the output, is limited. It's not all number, but starting from -4, and then the graph will go down. Means that the natural range is y less than equals to -4. The last one is the rational function. This is the simplest rational function, y equals to 1 over x. And if you plot the graph of this function, the graph looks like this. It has an asymptote. What is the domain and range of this function? Well, it looks like in the graph, the natural domain, it goes right forever and goes left forever. But there is one specific value that you cannot put in our function, which is x equals to 0. You cannot put x equals to 0 to our function. Why? Because when x equals to 0, your y will be 1 over 0. And you can put that into calculator, that will give you math error. Means that the natural domain of our rational function is all numbers, x real numbers, but x cannot be equals to 0. How about range? It's the same thing. The range looks like the graph goes up forever and goes down forever, but the graph will never touch y equals to 0. Why? Because when y equals to 0, we can modify this function into y equals to 1 over x, and then we multiply both sides by x, become xy equals to 1, and then x equals to 1 over y. The same thing. You substitute y equals 0, your x will be 1 over 0, which is once again error. Means that the natural domain of this case is y real numbers, but y cannot be equals to 0. There is an important concept in rational function that will be useful for doing past paper, which is this one. As x approaches infinity, what does it mean? It means that as x getting larger and larger, bigger and bigger, your 1 over x value will become 0. If you look at the graph, it goes down forever and then will approach x equals to 0. If you put, for example, y equals to 1 over x, and if we keep increasing the value of x, for example, x equals to 10,000, and you substitute, and then you will get 1 over 10,000, which is 0.0001. You increase the value of x, become 100,000, your y will be 0.00001. You keep increasing the value of x, your y will become smaller, smaller and smaller and approaching 0. And also same thing, as x approaches negative infinity, your 1 over x also approaches 0. Means that if you put a very big negative value, your function will be closer and closer to 0. It's the same thing. For this one, keep increasing the value of x, your y will become smaller, 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 and then approaches 0. Okay, let's do some past paper. Function f and g are defined as follows. Fx equals to 2x squared minus 4 for x bigger than or equals to 2. Just focus on this because the question just state the range of f. Now, if you look at the question, this is a quadratic function. So the key for the quadratic function, you need to find the vertex. So the vertex is, you take this number but take the opposite, minus 2 become plus 2. And then we take this value. which is minus 4. And because we know that the a value here are positive, which is 1. So that means if we draw the graph, this is 2, this is minus 4, and this is our vertex. And because a is bigger than 0, the graph will facing upwards like this. Now, because our domain is limited to x more than equals to 2, that means we just care about what happened in the function when x bigger than equals to 2. So from here and then bigger than, so goes to the right. So this one. As you can see, our range minus 4 is our minimum. Y equals to minus 4 and the graph goes up. So y more than equals to minus 4. We put equal sign because the domain also has equal sign. But sometimes the question, you need to do completing the square method first to find the range. For example, this one. The function f is defined as fx equals to 2x squared minus 16x plus 23 for x less than 3. Express fx in the form 2 times x plus a squared plus b. So first thing first, we write down the equation. And then if you look at the form, you have 2 outside the bracket. So this is the trick. You just factorize the 2 from these two terms. So that will give you 2 open bracket x squared minus 8x. So we take out the 2 plus 23. And after that, we do the completing the square for this part only. So the b value for this one is minus 8, right? A number in front of x. So we just divide by 2, you will get minus 4. So this is 2, and we put big brackets, square brackets, and then we put x in the bracket, and then we take the minus 4 here, and then square. But when we expand x minus 4 square, you will get x squared minus 8x plus 16. Using this formula, a minus b squared equals to a squared minus 2ab plus b squared. But in our equation, when we focus on this, we don't have plus 16. But this expansion has plus 16, so we need to minus 16 to eliminate that 16 from this brackets. And then we close the bracket again, and then we have the outsider, which is the 23. Now after this, very easy, you just multiply the 2 with the bracket. So x minus 4 square, and then 2 times negative 16, negative 32, and then you have the outsider plus 23. And yeah, you will get 2 times x minus 4 square minus 9. Now, after you complete the square, you do the completing the square, you can find the range easily. So use the completed square form, which is 2 times x minus 4 square minus 9. And then we take the domain. The question gives us the domain x less than 3. This is our domain, the x values, the domain. And then we do the vertex analysis. So the vertex is 4, minus 9, right? So because the graph is facing up, because your a is positive number, yeah, this is your a positive, means that when you plot the graph, it's look like this. 4 is here, minus 9 is here. So the graph looks like this. This is your vertex, and then it facing up because a is positive. Kind of like this. This is just a sketch, yeah. And after that, because we limit our domain, now our domain is not at the vertex, x less than 3. So this is 3. And then we want to find the y here. Because we limit the domain x less than 3, that means we just care about the part of the graph starting from 3 and then goes left because less than 3. Nah, if you look at the function, the minimum value is not -9. It's not our vertex. Sometimes it is our vertex, sometimes not. So that means we need to find the minimum value. You just substitute x equals to 3 to the equation because you want to find the value of y when x equals to 3. So just substitute y equals to 2 times 3 minus 4 square minus 9. So you will get 2 times -1 square minus 9. 2 times 1 minus 9, which is equals to minus 7, -7. Now, the -7 is our y value when x equals to 3. If you look at the graph, it's very obvious. Your range starts from -7 and goes up. So your range is y bigger than -7. Pay attention, I don't put equal sign because in the domain, they don't also put equal sign. That means 3 is not included. That means -7 is not included. We just care about what's after -7. So goes up, but -7 is not included. Okay, let's look at this question. We have another quadratic function, which is -2x squared, -8x, -13. And then we want to change it into completed square form as usual. So let's do it. This is -2 outside the bracket. So we need to take out the -2 from this. So you will have -2 times x squared plus 4x, and we have the outsider -13. Now from here, we just do completed square method. So we just care about what's inside the bracket here. So our b value from that is b equals to 4. We divide by 2 to get +2. And after that, we put a square bracket and then we put our x and put our value here, +2. And we square it. And then we check x plus 2 square is x squared plus 4x plus 4. If we expand this, you will get this, but it's kind of different because our function here inside the bracket doesn't have +4 as the extra. So we have to -4 to eliminate the 4 here. So we put again the -13. Now for that, easy, you just expand. So -2 times the bracket, and then -2 times -4 become +8, and then you have the outsider here, -13. And after that, you will have -2 times x plus 2 squared -5. Now, if you already get this form, it's gonna be easier to find the range because we know the vertex. The vertex is, we take this number but opposite, and then we take this number as the y coordinate. And then we focus on the domain. Sorry, the domain is x less than -3. So we write down here the domain is x less than -3, and then maybe we can sketch the graph to see what happened with the graph. We have the vertex -2, -5. This is our vertex. And because our a here is less than 0, means that the curve will face down like this. Nah, we just care about the domain now. The domain is x less than -3, right? So put -3 here, and we find the plot on the graph. We don't know this value, yeah. And after that, because we care about the part of the graph that is less than -3, less than means that you goes left. From here, you goes left. So we care about this part of the graph. So as you can see, the range starting from this value and go down. But what is this value? You need to substitute the -3. So you will get -2 times -3 plus 2 square -5. You will get -7. And after that, the graph start from -7 and go down. So the range is y less than -7 because go down less than. Let's look at the next question. In this question, we have different kind of function, which is a rational function. So let's look at how do we deal with this kind of function. So we have a function fx equals to 2 -5 over x plus 2. And then the question is same. We need to find the range of our function. Keep in mind that the range always depend on x. So our x or domain is always bigger than -2. That means we can put any value of x as long as it is larger than -2. For example, you can put -1, can put 0, can put 1, 2, 3, 4, and so on. So before that, let's see what happens if we put -2. If we put -2, our function will be fx equals to 2 minus 5 over -2 plus 2. This is what happens if we put x equals to -2. And what will you get? You will get 2 minus 5 over 0, which is math error. Why? Because we cannot have 0 in our denominator. That will give you error. So that means we cannot have x equals to -2. And also it's not part of our domain here. Now let's see what happens if we put a number bigger than -2. So if we put -1, so this gives you -1 plus 2, you will get 1. You put 0, 0 plus 2 equals to 2. Put 1, 1 plus 2 equals to 3. So no matter what value that we put here, the denominator always give you positive value. Because x is bigger than -2. So you can put -1, you can put -1.5, but this number always be positive. On top, we also have positive 5 if we exclude the negative. So that means all of this also positive because 5 divided by positive value always be positive. So in general, we have 2 minus positive value. And the value 2 minus positive always give you a value that is less than 2. Now, let's see the pattern. What if we keep increase the value of x? We put very big number, or we can say infinity. Infinity means it's just very big number. So what happened with our function? So our function is fx equals to 2 minus 5 over infinity plus 2. But infinity plus 2 is just bigger number. So 2 minus 5 over big number, this part, the fraction part, will approach 0. That means your value will approach 2. It's not equal to 2, it just approach 2. So that means by looking at the pattern, this one is math error. This one is value always less than 2 and your value always approaches 2. So that means your range is fx or y also works is always less than 2. But not equals to 2 because it's just approaching 2. Not equals to 2 will not reach 2. So this is our answer. Move on to the next question. We have another two function. We have fx equals to 3 over 2x plus 1 and gx equals to 1 over x plus 2. As usual, we look at the pattern. Yeah, let's see our domain. Both of the function have same domain. So we can put any value of x as long as it is bigger than 0. For example, 1, 2, 3, and so on. You can put very big number as well. Now, before that, as usual, let's see what happens if we put 2. Will it give us error? So put x equals to 0. So that gives you 3 over 2 times 0 plus 1, which is equals to 3. Now it's different. Before it's math error, but now it's not. you have a value for that equals to 3. And see what happens if you put x bigger than 0. So you have 3 over 2 times x plus 1, but x is bigger than 0. So all of this positive, 3 over positive value. So this will give you positive value. And what if we keep increase the value of x? So 3 over 2 times big number plus 1. All of this is same thing as bigger number. So 3 over infinity or big number. So this will approach 0. The same thing as before. A number divided by very big number that will approach 0. So now this is the range. We have 3 and 0 as our boundary, and in between we have positive value in between 0 and 3. So our range of fx will be fx is in between 0 and 3. This is our minimum, this is our maximum. And how about gx? Same thing. We substitute x equals to 0. What happened with our gx? 1 over 0 plus 2. This one is math error, so we cannot have x equals to 0. And then we have x bigger than 0. So you have 1 over x plus 0. So all of this will become positive because 1 over positive value is always positive. So you have plus 2. So that means it is positive number plus 2. That means always larger than 2. And the last one, if we put very big number, x approaches infinity. Yeah, let's see what happened. 1 over infinity plus 2. This will approach 0. Same thing. So this will approach 0 plus 2, which is equals to 2. But only approaching 2, not equals to 2. So that means the same thing as before. This is the boundary, but we'll never reach this, and then your value will always larger than 2. So that means your gx is larger than 2. Cannot put equal because that will never reach 2. It's just approaching